Hey, so today, in this video, we're going to be covering 3.4, chapter 3.4, which covers 4 different things. The rational zeros theorem, Descartes' rule of sign, finding zeros, and then the upper and lower bound, like finding upper and lower bounds. These look very intimidating because they're like new math terms that we haven't seen before, but they're actually not too bad. So we'll just get into it. So question 10 is one of the questions on our homework, and it basically says let me open it up. It says use the rational zeros theorem. List all possible rational zeros given by the rational zeros theorem, and then we don't need to actually check to see which are zeros. And then the problem that it gives us is u of x is equal to 12x to the fifth plus 6x to the third minus 2x, and then minus 8. And then what we want to do is we want to take our coefficient of our first term, because when we're thinking about this, kind of the middle terms are not really relevant. We want a constant, so one that does not have an x. And we want the highest degree, our leading term coefficient, 12. And what we're going to do is we're going to take the leading term and put it on the bottom, so plus or minus, and we're going to factor it and put it on the bottom. So for example, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. These are all the factors of 12. And then for the top part, we're going to put all of our factors for our constant. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And typically, it will not be this weird or wonky, but usually this will be like a 1, and then it will make things really easy. But they kind of want to teach you the right example with this. So what we're going to do is we're going to take this, we're going to look at one at a time. So we have this plus or minus 1. And we're going to say, okay, if I put this on the top, and if I put this on the top, and this on the top, and this on the top, those are all possible rational zeros. So 1 divided by 1 is 1, plus or minus 1. And all of these will be plus or minus. 2 divided by 1 is plus or minus 2. 4 divided by 1 is plus or minus 4. And 8 divided by 1 is plus or minus 8. Next, so those are those. And I'm going to cross this out because it's not needed anymore. Then we're going to move on to positive 2. And say, okay, 1 divided by 2 is plus or minus 1/2. 2 divided by 2 is 1, which is already listed here. I'm going to box the ones where it goes under. 4 divided by 2 is already listed here under positive 2. And then 8 divided by 2 is already listed here. So that takes care of those. Yeah, we just don't need the repeats. We'll skip to green because yellow kind of doesn't show up. Next, we'll be looking at plus or minus 3. So we'll have 1 divided by 3, so 1/3. Plus or minus 2 divided by 3, so 2/3. Plus or minus 4/3. Plus or minus 8/3. We're basically doing division with the top and the bottom. And that takes care of these. Next, we'll move on to plus or minus 4. So 1 plus or minus 1/4. 1 divided by 4. And then plus or minus 2/4, which is already listed as 1/2. And then plus or minus 4/4, which is already listed as 1. And then plus or minus 8/4, which is already listed as 2. So that takes care of that. Next, we'll be moving on to positive 6, plus or minus 6. So we'll have plus or minus 1/6. 2/6 is already listed as 1/3. 4/6 is already listed as 2/3. And 8/6 is already listed as 4/3. So that takes care of that. And then we'll move on to purple, and we'll say plus or minus 12. So we'll have plus or minus 1/12, plus or minus 1/6, 2/12, which is already 1/6. Let me get rid of that really quick. Plus or minus 1/6. Plus or minus 4/12, which is already listed as 1/3. And then plus or minus 8/12, which is already listed as 2/3. So those are all of our possible rational zeros, and that is what the question is asking for. You could put commas in between them. You don't need the boxes around them. I'm just demonstrating what is going on here. So these are, and in this case, we should have 12. Yeah, so these are all of our possible rational zeros for this prior equation. And I scribbled it out, but it'd be the 12x to the fifth, 6x cubed, minus 2x minus 8. And that was the possible rational zeros theorem. It's fairly simple. Usually it's a lot more simple than this was. They just wanted to show that, like, how to do it, basically. And what this is good for is it tells us, like, if we were to graph, here are some possible points on our graph where it's an x-intercept. It doesn't give any irrational ones, so like no square roots or anything like that, and it doesn't give you any imaginary ones either. But this is useful, and we'll show why it's useful in a little bit. But first, before we do, let's talk about Descartes' rule of signs. So Descartes was this old mathematician, and I don't know how he figured this out, but basically he said, let's say we have a problem, and I'm going to choose a problem from our homework. Let me see. I don't know if this is one of our assigned homeworks, but like say we have something like x to the 8th minus x to the 5th plus x to the 4th minus x cubed plus x squared minus x plus 1. And what he figured out is, here's for as many sign changes you have. So let's look. We have a positive to a negative to a positive, positive to a negative, negative to a positive, positive to a negative, negative to a positive. We have 1, 2, 3, 4, 5, 6 like sign changes. But what Descartes found is he said, if there are, for as many sign changes, that's how many positive real zeros you have, possible positive real zeros. So 6, but also you can go down by 2. So 6 or 4 or 2 or 0. Alternatively, if you had found something like 5 different sign changes, then you would do 5 or 3 or 1 positive real zeros. Basically, you just go down by 2 to find out your possible amount of real zeros, positive real zeros. The next part of so that was for our positive real zeros, and that's fairly simple. It's like, oh, here's a positive to negative, negative, positive, blah, blah, blah. And this next part is also fairly simple, but you got to be careful a little bit when you're getting to that point, because what we're going to do is we're going to plug in f of negative x. We're going to plug in our negative x into our equation above, and then we're going to do basically the same thing to see which signs are changing. So the long way about this is negative x to the 8th minus negative x to the 5th minus plus negative x to the 4th minus negative x to the cubed, x cubed, and then plus negative x squared, and then minus negative x, and then plus 1. And a certain pattern that you're going to see is, so if it's an 8, that means that we've got positive times a positive 4 times. I mean, a negative times a negative 4 times. So this is actually just going to stay positive. The negative is going to cancel out. But with this 5, it's going to leave you with a negative, so you can change this sign to be positive x to the 5th. Similarly, this one is going to stay positive because it's already it's to the 4th, to an even power. This one's going to change signs to a positive because it's to an odd power. This one's going to stay the same because it is a even power, so x squared. This one's going to change, so plus x, and then plus 1. Basically, so that's the long way of doing it. But basically, you could say, okay, I see an x to the 8th here, the sign's going to stay. I see an x to the 5th here, it's going to add because it's an odd thing up there. This is going to stay the same because it's a 4. This is going to add because we have a 3. And then this is going to add because we have a 1. This is going to stay the same because we have a 2. And this is going to stay the same because there's no x at all. Alternatively, if you had something like positive x to the 3rd and you plugged in a negative, it would change to negative. It doesn't just make it positive, it just flips the sign for the odd ones. So hopefully that makes sense. And then what we're going to do is well, theoretically, if you remember that, then this is super easy to figure out. This part down here is super easy to figure out because it's like, oh, this stays, this plus, like that kind of thing. It shouldn't take you too long. Obviously, the beginning parts is, while you're getting used to it, it might, but basically the next thing that we want to do is basically the same thing that we did up here. Are there any sign changes? No, this is a positive to positive, positive, positive. There's not a single negative in here. They're all positives. So there are 0 negative real zeros. So that's Descartes' rule of sign. You basically find that. So why this is important is because it can help us figure out, like, number one, which zeros that we found up here to test. Like, in this example, we don't have any negative zeros. So when we're testing, we only want to test the positives. That's really helpful because it narrows down 12 different options in this one. And potentially more depending on how many positive real zeros you have. But, so yeah, that's very useful. And then the next thing that we're going to talk about is kind of combining them and finding zeros, the actual zeros. So we found possible zeros and we found how many positive and negative zeros we'll have, but we need to find the actual zeros. And a way that we can do that is we can take, hold on, let me get rid of this. Oops. So the way that we can combine these all together is we can take our, so let me find an equation. Let's say we've got something like x to the fourth minus x cubed minus 23x squared minus 3x plus 90. And we can say, okay, first I'm going to try my rational zeros theorem. This is maybe a gross one to do for an example. I'm actually going to choose something else. I don't know if that's an actual problem that you've got in your homework. It would be doable. I just want to do something quicker. So we've got x cubed minus 6x squared plus 12x minus 8. And first I'm going to do my rational zeros theorem. And to do that, I'm going to take my plus or minus 1 on the bottom, because this is a 1 here, a hidden 1. And then I'm going to do plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And what this basically gives me is plus or minus 1, whoops, plus or minus 2, plus or minus 4, and plus or minus 8 for my possible zeros. Next, I'm going to do Descartes' rule of signs to figure out which one of these are valid or not. So, not which one of these are valid, to figure out how many positive rational real zeros I have. So here's a sign change, here's a sign change, here's a sign change. So I have 3 or 0. Whoops, I'll do 3 or 0. I don't have to write it out. 0 positive rational zeros. And then for negatives, this x cubed is going to change. This negative 6x squared is not. This 12x is going to change. And this negative 8 is not. So there are 0 negative zeros. So I know when I'm going to be doing this next part that we're about to learn, that I don't need to worry about any of these negative numbers, only the positive ones, because there are 0 negative zeros. So this next step, we're kind of going to be combining what we learned in the previous chapters with our synthetic division. And we're going to say, okay, I know that we know that if our remainder is 0 when we synthetically divide, then that thing is going to make whatever was in the top corner that we were synthetically dividing by is going to be one of our zeros of the equation. We found that out in like 3.3 or 3.2, I don't remember which one. But basically we'll take out this one. I like to test out the smaller numbers first. It doesn't matter which one you test out first, but that's what I personally like to do. And I'm going to say, okay, I have a 1, I have a negative 6, I have a 12, and I have a negative 8. I'm getting these numbers from this equation. And I'm going to see if 1 is a 0 of my equation. So I'm going to drop this 1 down. 1 times 1 is 1. Negative 6 plus 1 is negative 5. Negative 5 times 1 is negative 5. This gives me 7. 7, negative 1. So this is not a 0. I can ignore that for a minute. I'm going to try positive 2. 1, negative 6, 12, negative 8. Drop it down. 1, bring it up. 2, negative 4, negative 8, positive 4, 8, 0. So 2 is a 0. Now there are two, well, first, before we do anything else, I know, because I synthetically divided, that x minus 2, firstly, I know that this is a 0, because if I plug in 2, this whole thing will turn to 0. So this is one of my factors. And then I'm going to take my quotient, which is x squared minus 4x plus 4. So this is what we have so far. But this can be factored more, and this question is going to ask us to factor more. So what we need to do is either, there are a few ways that you could go about this. You could test 4 synthetically dividing with this, or 8 synthetically dividing with this, or 4 or 8 synthetically dividing with this new equation, and that is totally valid. But what I would recommend is you just factor this by hand once you get down to 3 different terms. Because then you will be able, it will help you, number one, it will help you in 3.5 when you are, because you'll have to be finding some complex and irrational numbers, and it will help you later in 3.4 when you do need to find some irrational zeros by using the quadratic formula. So I super recommend doing synthetic division until you get down to 3 or 2 terms, and then just factoring by hand after that. And so in this case, a times c is 4, it's because 1 times 4 is 4, and then the factors of 4 that will add up, that will multiply up to positive 4 and add up to negative 4 is negative 2 and 2, negative 2 and negative 2. So we'll have x minus 2, x minus 2, and x minus 2, because this stays from here, but this will factor down into this, right? So we'll have an x minus 2 cubed. Basically, we'll have a 1, 0 with a multiplicity of 3. So our positive 2 with multiplicity 3. Which is not what it's asking for. What it's asking for, at least in this problem, the one that I was doing, which was, I believe, 19 in 3.4, all it's asking for is this factored version right here. Later in the homework, I believe, I don't know if it's in 3.4 or 3.5 or both, but later you'll need to factor this out like this and then like actually FOIL it, kind of. But for this one, you just need to write it in factored form like this. Yes, so that was adding, like putting those all together and then finding the zeros with that. Finally, what we need to do is find upper and lower bounds. And basically, what upper and lower bounds are talking about is sometimes you'll have a graph. It doesn't matter what the shape of it is, but we'll have a variety of different zeros, like one here, and one here, right here. What an upper bound and a lower bound is saying, so this would be our lower bound, and this would be our upper bound. What this upper bound is saying is basically we don't have any more x's past this point. No more x intercepts. We don't have any more x, like no more zeros. And what our lower bound is saying is we don't have any more zeros this way either, before this point. So this is all well and good to know what it is, but how do we find upper and lower bounds? Well, we will take our equation. I'm going to pop up the last thing that we just did. We found, actually, let's just do a whole another equation, because that will maybe be good. For example, in our homework, it's giving me something like 8x cubed plus 10x squared minus 39x plus 9. And then it gives us a is equal to negative 3 and b is equal to positive 2. Luckily, we do not have to find the zeros. It's saying, is a an upper bound? And a lower bound? And then it's saying, is b an upper bound? And the way to find that is synthetically dividing again. So we're going to put our negative 3 into our little box up here. So 8x cubed. We don't need the x cubed, sorry. 8, 10, negative 39, and 9. And we're going to just synthetically divide. So negative 24, negative 14. I believe this was negative 42, positive 42. So this drops down and gives us negative 3, which gives us positive 9, which will give us 0. Oh, wait. No, positive 3 and then negative 9. My bad. 0. And if it is a lower bound, then the signs here are going to alternate. So we have a positive and a negative, and then a negative to a positive. And so we know that negative 3 is a lower bound. Next will be b. So we're going to synthetically divide with this too. So 8x cubed plus 10x squared. We do not need the x cubed, sorry. I've been doing so much math today. Negative 39, 9. And then what's going to happen is we'll drop this 8 down. 8, 16, 26, 52 again, I think, and then 13, if I remember correct, and then 13 times 2 is 26, and then it will be 35. And then to find if it's an upper bound, all of these will need to be positive as well, I think. So this is 2 is an upper bound, because all of these terms right here are positive. There's no negatives here. So alternating, if it alternates, it's a lower bound, and if it's all positive, then it's an upper bound. And that is the totality of 3.4. If you have any questions on your homework, please let me know, and I will go more specific. But yeah.